Hello, can you hear me?
Yes, sir.
This was problem 60 that I said yesterday. Have you tried it?
Yes, sir.
What are you getting?
Sir, the solutions are 3, 7, 733. It's the different permutations. Sorry.
Okay, that's correct. All permutations of this. So how do you do it?
सर तो बेसिकली जो RHS है वो 3 से डिविजिबल है और जो 18 है वो भी 3 से डिविजिबल है, तो हम एक क्लेम दे सकते हैं कि PQR में से कोई एक तो 3 होगा।
Hmm.
तो विदाउट लॉस ऑफ जनरलिटी हमने ले लिया कि R जो है वो 3 होगा। उसके
Hmm.
बाद फैक्टराइज कर दिया और सॉल्व कर दिया।
Once you put one of them as 3, you will get something like this, hopefully.
यस सर।
727.
यस।
And then again, you have to think of factors and try 727 also turns out to be prime.
यस सर।
So after that, you have to look for factors and you'll get this. So this is fairly straightforward. Problem 61 was the sequence problem, where A3 was given as 2019 and AN plus 1 was equal to 2 power n minus 3 AN times AN plus 1 plus 3 for n greater than equal to 0. You have to find A0.
Sir, I am getting under root 375 minus 1 by 2.
You made a silly mistake. It is under root 385.
अच्छा। Sir, but
Yes, sir. This is the answer.
I have a doubt in this question, but
Hmm.
मैंने हर एक का वैल्यू निकाला है, मतलब मैंने A2 निकाला, फिर A1 निकाला, फिर मैंने A0 निकाला, बट
That's
कोई
the way to
डायरेक्ट,
do it.
मतलब कोई डायरेक्ट वे नहीं है इसका।
That
मतलब
is the correct way to do it.
ये एक
If there,
रेकरेंस तो
it is a recurrence, but the easiest way to do it is what you have to find A0, A1, A2 and all.
बट अगर अगर ऐसा होता कि इस A3 की वजह हमें A10 दे रखा होता तो प्रॉब्लम बहुत कॉम्प्लिकेटेड हो सकती थी। तो
Then you will have to solve the recurrence, but that is much more difficult. You can try solving the recurrence. You have to look for patterns where this can be written as probably 2 square minus 1, and you will get an plus 1 is equal to 2 power n minus 3 an plus 1 plus 2 square. And you will try to see if you can get a pattern from here. But that solution of the recurrence is a different topic that for IOQM, you don't need to worry about it. There are many other ways to solve recurrences. Either you guess a nice pattern like this, or you use generating functions. Basically, that is a separate topic, which you don't need to worry about for IOQM at least. For now, the solution is by guessing small values, by trying to find A0, A1, A2. Maybe at a slightly later stage, we can discuss how to solve recurrences in general, but that is not right now. Has everyone gotten this? This should come if you try to make equations using n is equal to 1 and 2 and so on, you'll get it. Okay. Problem 62 was the number question. 13-digit number was there which was divisible by 101. 13-digit number n which was having digits A, B, C, D, E, F, G, H, I, J, K, L, M is divisible by 101. And then you have to find digit A given, it is also given B, C, D, E, F, G plus 2019 is equal to H, I, J, K, L, M. Has anybody tried this?
Sir, I wasn't able to get this question's answer.
Okay. What about you, Aman?
the solution.
Huh?
सर सोल्यूशन नहीं निकला इसका।
Okay. So first thing is to try to think about this number. It is 13-digit number n is equal to, basically you can say a into 10 power 12, right? Plus you can say this part, this 6 digit into 10 power 6, right?
Yes.
Plus the last digits. Do you agree with this, that this is correct? You can check it with some numbers also. Like if you have let's say 5-digit number, 2, 1, 3, 4, 5. We can say it is 2 into 10 to the power 4 plus 13 into 10 square plus 45, right? I
Yes.
hope everyone is following that this pattern only I have done here. Correct, no?
Yes.
Okay. Now we have to also think about divisibility by 101. So let's think about it. This 10 power 6 is there. So if I look at the number 10 power 6 plus 1, that is actually 10 square whole cube plus 1 cube. And by writing it as x cube plus y cube, you'll get 10 square plus 1, x power 10 power 4 plus 1 minus 10 square, right? So can you see that 10 power 6 plus 1 is divisible by 101?
Yes.
We are getting 10 power 6 plus 1. 101 divides this, right?
Yes.
Correct. So we can say 10 power 6 is congruent to minus 1 mod 101, right?
Yes.
I hope everybody is understanding this. So
Yes, sir.
from here we'll get 10 power 12 is congruent to what mod 101? 10 power 12 करोगे तो क्या हो mod 101?
1 mod 101.
If 10 power 6 is minus 1 mod 101, then squaring it, you can do that in modulo. So you'll get 10 power 12 is 1 mod 101, right?
Yes.
Great. So now if you look at this number n mod 101, what you will get is 10 power 12 तो 1 हो जाएगा, right? 10 power 12 will become 1 mod 101, right?
Yes, sir.
So you will get n mod 101 is congruent to a, because a into 1, and 10 power 6 is minus 1, right? So minus whatever is this number b, c, d, e, f, g plus this number h, I, j, k, l, m mod 101. I hope everyone understands this step.
Yes.
Yes, sir.
Great. And in the beginning of the problem only, they have said the difference of h, I, j, k, l, m minus b, c, d, e, f, g is 2019, right? 2019 is what mod 101? Let's find that. Find that out.
It's minus 1.
Correct? Is it minus 1? Have you checked?
2020 divisible होगा उससे 101 से.
So 2019 is congruent to minus 1 mod 101, right? Correct?
Yes.
So यहाँ पे देखो n was divisible by 101, so it is 0 mod 101, right?
Yes.
So is congruent to a, and this part is, we have just seen from the condition in the problem, it was minus 1, right? Correct?
Yes, sir.
So A should be what? A should be 1 mod 101.
Yes, sir.
Okay. So A is 1 mod 101. So we have to find that digit A, right? So we have digit A. So A will be 1 then, right? 1 second, let me think. We are getting A is 1 mod 101. That much is for sure. Can it be any other digit though? No, right? Any other digit, the digits value can only be from 1 to 9, right?
Yes, sir.
The place value, A is a digit, it's a place value. No, वहां पे तो 1 to 9 ही डाल सकते हैं, right?
Yes, sir.
So if it has to be 1 mod 101, then it implies that A is 1, right?
Yes, sir.
Because any other one, any other number here would be 2 or 3 or 4 mod 101. Is it clear, everyone?
Yes, sir.
Yes.
So basically a nice question where we took advantage of the fact that n was divisible by 101. So for that, we took everything mod 101. And in order to expand it and use the fact that 6-digit numbers were being used, we also broke down n in this way, which is a nice trick. This you should know. We broke it down like this and then thought of 10 power 12 and 10 power 6 mod 101. And if you think of that, the problem is solved. I hope everybody is following.
Yes, sir.
Okay.
Yes, sir.
Problem 63 then. Uh, solve in complex numbers. In complex numbers, the system of equations the system of equations 2019 by z minus 2w is equal to 12 minus 23i, and 2019 by w minus 2z is equal to 12 plus 23i. This is the system of equations. We have to solve for z and w, and they could be complex numbers also. It's not very difficult. You just have to simplify it a little bit. You will be able to solve it. Just simplify the equations a little bit, it will come. You don't have to type in the chat, you can say it also. Shlok, hi. You can watch the previous videos. The playlist is there on the channel, on the YouTube channel. All the previous videos also you can see. There are a lot of problems. If you try the problems yourself, then you will be able to learn from them. Don't just see the solutions without trying. Try to solve the problems yourself, then you will learn from it. This is taking too long, guys. Why is it taking so long? Everyone should be able to solve this.
Sir, actually a quadratic equation came, so trying to solve it.
This situation everyone has seen, right? If you change the equations like this and take ratios, you will immediately get 12 minus 23i z divided by 12 plus 23i w is equal to 1, right? Can you see that this is coming? And if the ratio is this, then z is what? Z is 12 plus 23i divided by 12 minus 23i times w. I hope everyone is understanding the step here, what we have done so far.
Yes, sir.
Now
I got
you
this thing, but I wasn't able to solve afterward, like substitution. There was a quadratic, I wasn't able to solve.
now you have to put this z back into the first equation. Let's say this equation, right? You aren't able to solve the equation. You should be able to. It's not so difficult. Let's put this z back. You will solve for w then. You will get 2019 is equal to 2w times z, which is 12 plus 23i by 12 minus 23i w plus 12 minus 23i z, which is again 12 plus 23i by 12 minus 23i w, right? This cancels and we have this expression 2 times 12 plus 23i by 12 minus 23i w square plus 12 plus 23i w minus 2019 is 0, right? I hope this is clear. I've just made it a quadratic in w. After that, solving it is direct putting in the quadratic formula. Put it in the quadratic formula and simplify it. W will be negative of 12 plus 23i plus minus root over b square. So 12 plus 23i whole square minus 4 into this. So plus 4 into 2019 into 2 into 12 plus 23i divided by 12 minus 23i by 2 times this. Okay, this looks big, but it is not going to be super difficult. You have to simplify it a little bit, but it is possible to do it. We can take common denominator here, multiply once by the conjugate. You will get 12 square plus 23 square. 23 square multiplied by 12 plus 23i. Plus we have 8 times 2019 into 12 plus 23i. Whole thing is divided by 12 minus 23i. This whole thing is under a root. Great. So this can be taken common, right? 12 plus 23i common divided by 12 minus 23i. And inside now you have 12 square plus 23 square plus 8 into 2019. That's it. 12 square plus 23 square plus 8 into 2019. 2019 is divisible by 3. We know it is 3 into 673. So 2 into 12 into 23 is what? 24 into 23. 24 into 23. Okay, it is not coming as a simple factor amount. You will have to calculate this out. Everyone knows how to take square root of a complex number.
Yes, sir.
So square root of a complex number is possible. The question is a little long. It's fine. The answer, I will tell you the answer. You can check it later. I don't want to spend time doing it. Answer is W is this, Z is this. So actually the ratio was simply 1 and all. You can check the answers later. The problem is actually simple, so I don't want to spend time on it. It's just calculations. We'll go to the next problem. Okay. Problem 64. In quadrilateral ABCD, angle A is equal to angle B is equal to 60 degrees. Mod of AD minus BC is equal to 13. And CD is equal to square root of 2019. Find AB knowing that it has integer length, and that the perimeter of ABCD is as small as possible. You have to find the side length AB, where side length is an integer and the perimeter of ABCD quadrilateral is as small as possible. I hope everyone can see the rough figure I have drawn. Angle A and angle B are 60 degree. Mod of AD minus BC is 13. And CD length has been given as root 2019. The perimeter of triangle ABCD, quadrilateral ABCD is as small as possible. Let me know if anybody is getting any ideas. This is a tricky question. You have
Sir,
to.
I have an idea, I guess.
What?
Sir, basically we can try by producing AD and BC to form an equilateral triangle,
Okay, that's the correct idea.
and then
We can call it E.
then we can assume the side length of AB to be like something, and we can apply the cosine rule in triangle EDC.
So this must be X then, right?
Yes, sir.
First of all, it must be equilateral because this is 60, this is 60, right?
Yes.
If this is X, we can say that AD is bigger than BC by 13. So let's call EC as Y for now. E to C is Y, let's say. Then this must be Y minus 13, right? Correct?
Yes.
The difference between AD and BC, AD and BC is 13. So therefore, I'm saying Y and Y minus 13. I hope everyone is understanding what I'm saying.
Yes.
Then cosine rule in the triangle ECD for angle 60. You can say cos 60 is equal to y square plus y minus 13 square minus 2019 by 2 into y minus 13. And this is half, right? So basically you get y into y minus 13 is equal to y square plus y minus 13 square minus 2019. And we have to simplify this equation. Becomes y square gets cancelled from here, minus 13y here is equal to y square minus 26y plus 169 minus 2019. You have y square minus 13y minus 1850 is 0. Correct?
Yes.
Now 5 into 37 is 185. So 50 into 37 basically. You will get y minus 50 and y plus 37 is equal to 0 from there. Y is equal to 50 is coming. Right?
Yes.
If y is equal to 50 is
Yes.
coming, then we can now look at, we have to make the perimeter as small as possible, right? So, and it has to be integer also, no? Integer sides also, right?
Yes, sir.
So ये 50 अगर हो गया इतना, so you can make it 51, right? One more.
Yes, sir.
Because AB has to be bigger than 50 now, right?
Yes, sir.
So X should be 51 then. And then all three sides are 51. And this is Y minus this is 37 and this is 14 then. Right? And
Yes,
this
sir.
is 1. Basically, you're getting 51, 1, 14, and root 2019. These are the shortest perimeter quadrilateral with AB being an integer. How did we come to 51? Because we knew that AB must be bigger than 50. So next integer is 51. I hope everyone is
Yes.
following what is happening. Is it clear to you, Aradhya?
Yes, sir.
Okay, fine. The next one is not very difficult. You have to solve in real numbers the equation minus solve in real numbers this equation. Anybody, anything?
Sir, I didn't get the answer yet, but I have a method.
What
So
is the method?
1019 minus x can be taken as t.
Okay.
It will help. No. Oh, I'm doing a mistake. Sorry, sir.
Hmm. Right. See, you can say u is equal to this and v is equal to cube root of this. And right now the equation is basically u minus v is 16. What will happen if you do u square? U square is 1019 minus x. And what is v cube? 2019 plus x, right? So if you add these two, what happens? X will get cancelled, right? You will get 3038 is u square plus v cube. Correct? So that is a simple equation. No?
Yes.
Now you can say u is 16 plus v, right? And put that in this. You will get 16 plus v whole square plus v cube is 3038. You will get 256 plus v square plus 32v plus v cube is 3038. And basically we're getting v cube plus v square plus 32v minus 2782. This is what we are getting. So now the thing is, can we guess a root? Because there is no standard process for such situations. Can you think of a root which will basically something whose cube plus square plus this adds up to 2782? If you start with 10, for example, 1000 plus 100 plus 320. It is not close right now, right? You're getting 1420, right? So obviously it should be bigger than 10. So let's take 12. 12 cube is 1728 plus 144 plus 32 into 12 would be 320 and 344. So still little bit less, right? I hope everybody is understanding what I'm saying. Is it clear what I'm saying right now?
Yes.
Yes, sir.
So 12 is also less. So let's try 13. And when you try 13, it will fit. Try it out. You will get 13 is a root. So then you will take v minus 13 as a factor. When you take v minus 13 as a factor, the thing that comes inside doesn't have any real roots. So basically 13 is the only root. And if 13 is v, then u is clearly 29. And if u is 29, then using this equation, we can find x. 29 square is 841. So 841 plus 178 is 1019. So x is 1178. That becomes your solution. It is a little bit of guesswork at this step. When you come to a cubic, you have to guess a root. So a little bit of guesswork, but if you're smart about it, you don't have to guess more than 2-3 times. Is everyone following what I'm saying?
Yes.
2-3 numbers try करना होगा तब पता चल जाएगा क्या हो रहा है. Okay. I will give you guys some practice problems for tomorrow. Some of the problems are similar to what we have just now discussed, so that will test whether you understood or not. So problem 66 is exactly similar to what we did today. There is a 10-digit number n, which is written as A, B, C, D, E, F, G, H, I, J. This 10-digit number is divisible by 27. You have to find the digit A given BCD the number plus EFG plus HIJ adds up to 2019. This is what is given. Very similar to the question that we solved today. So you should be able to try it out and do it. Problem 67 is let m and n be integers such that m plus n is equal to 2019. You have to prove that m cube plus n cube plus 9mn is divisible by 27. And problem 68. Right. Problem 68 is this one. Let A, B, C be real numbers such that 2019 times A square plus B square plus C square minus 1058 times AB plus BC plus CA is equal to 7115. There is also some data that is given. If mod of A minus 13B plus 43C is equal to 55 and mod of 43A plus B minus 13C is equal to 57, you have to find out what is the mod of minus 13A plus 43B plus C. Write down the numbers carefully because obviously if the numbers are wrong, then your question cannot be solved. A, B, C are real numbers such that 2019 times A square, B square, C square minus 1058 AB plus BC plus CA is equal to 7115. And then two modulus values are given. Mod of A minus 13B plus 43C is 55. And mod of 43A plus B minus 13C is 57. You have to find out the modulus of minus 13A plus 43B plus C. I hope the other problems are clear enough.
Yes, sir.
Okay, so these three problems we'll discuss and more in the next class. Okay, I'll see you guys then. That's all for now.
Good evening, sir.
Yeah, bye.